Hey everyone, welcome back. So today we'll be discussing about missing values and outliers. So this is the part two of feature engineering. So okay, let's go. So what is mean by missing values? So when we do the data acquisition, the data may be missing in some of the data sets. Like let us suppose you have accused CSV file. Okay, one minute. Okay, accused CSV file. So in this CSV file, let us suppose there are four features. Okay, there are one, there are four features. Okay, there are four features. So feature one, I mean zero, one, two, and the last one is target. Okay, okay. In this, in this, okay, the missing value, this the data at this point is missing. Okay, so what we'll do? We will remove this entire row. Okay. So the problem is when there is a that more amount of data is missing, then we can't remove the entire data set, right? If there are, if you do like this, we can see most amount of the data will be removed because of this particular reason. So to overcome this, we have some imputation techniques that can be performed. Okay. So how we can handle the missing values? Missing values. Okay. First one is how we can handle by removing just by removing the entire row. And the second one is imputation. Okay. Imputation. Impute. Impute the values. So what is mean by impute? Okay. So I will be taking an example of this. So to fill this value, I need to use if it is a numeric data. Let us suppose it is a numeric data. So this is x1, x2, x3. Okay, x3 is equal to x1 plus x2 by 2. So this is mean of the entire column. Okay, we can replace it by mean. If it's the categorical data, then we can replace it by mode. We can replace it by mode, or we can replace if the data is skewed, then we can replace it by median. If it is normal, then we can replace it by mean. Okay, we'll be discussing what is that. Okay, so impute. So here in this, there are two types. One is univariant, and other one is by multivariant. Okay, so in univariant, numeric data, and categorical data. Categorical data. In this KNN imputer, we'll be discussing what is the KNN imputer, KNN imputer, impute, and other is iterator, iterator imputer, iterative imputer, anything. Okay. Okay. So when we should use mean and when we should use median. Okay. When you should mean when the mean is can be used when the data looks like it's normally distributed. If it is normally distributed, then we can use the mean. If it is not normally distributed, then we should use median. If it is skewed some left skewed, then we should use the median. So it can give the it will give the higher accuracy when we perform the model training. Okay. So in the In the case of categorical data, in the case of categorical data, we can use mode. Okay, cool. Like how many, the most number of repeated. Okay, the most number of repeated items can be known as mode. We can replace the missing values this mode with mode. Okay, I understood, right? Okay, so what is we have univariate? We have completed this. Okay, so what is multivariate KNN imputer? Okay, what is KNN imputer? KNN imputer. Okay, so what is mean by KNN? KNN means K nearest neighbors. Okay, nearest neighbors. So now you understood by the name, it will it will give the value of the missing number with the nearest items. Okay, let us suppose 1, 2, dash 4, 5, 6. Okay, nearest k equal to 3. Let us suppose this value is missing. So we can see the values like this: 1 plus 2 plus 4 by 3 equal to 7 by 3. It's around 2.33, right? Or you can use here also 1 plus 2 plus 5. What plus 4 can be by 3. It is 11 by 3. It's 3.6. Okay. So rather than deleting the entire row, we can use this KNN imputer to find the nearest neighbor and give the value to the missing number. That is a 3.6 in this case. Okay. So this is the KNN imputer. So other one is predictive imputations. Okay. Predictive imputations. Predictive imputation. So in this, we use the ML models. We use ML models to predict the missing values. Okay, all right. To predict the missing values, we use the ML models to predict. This is the prediction, predictive imputations. Okay, or to avoid these missing values, this everything stuff, just use the boosting algorithms. Use boosting algorithms. Boosting algorithms. These are the machine learning algorithms similar to linear regression, multiple linear regression, something. It is same as an algorithm. It's a different algorithm, and there are many types as XGBoost, AdaBoost. Every boosting algorithm can be used to avoid these missing values. So now you understood, right? So missing values are can be treated by using two types. One is removing, another one is imputations. Imputations are classified into univariant and multivariant. Okay, univariant are numeric and categorical. In numeric, we use mean and median. In this we use mode. Okay, in multivariant we use Canaan imputer, which neighbors, neighbors, and we'll be discussing iterative imputer in upcoming videos. Okay. So, and also KNN imputer we have completed. Next, predictive imputation. So we use the ML models to predict. Okay. And the last one, to avoid this missing values problem, we can use boosting algorithm also. Okay. So now we will see the coding part of this. Okay. Now let's see the coding part of the missing values. So I've imported all the libraries that are required to impute the missing value. Like I've loaded the iris dataset and trained text split. for splitting the data set into training and testing data. We know that we should not apply on training testing data. Okay, we should not apply imputing on testing data. Okay, so, so for now, let's apply on entire data set. Okay, now I have loaded the data set. Okay, and I have converted it into a data frame. Okay, let's see how the data set looks like. Okay, oh, I'm sorry. So the data set, the iris data set does not contain the 1 minute. So iris data set does not contain the missing values predefined. So I've added the missing values. Okay, so is null dot we get zero missing values. Okay, so I've added the missing values. So now let's see the okay, we got around 30 missing values. Okay, we got around 30 missing values. Okay, so across the data set, not across the not in only one column. It's around across the data set. Okay, so the data sets now it looks like see there are four features and one target. Okay, you can see the nan value that we have introduced using this code. So it's generally introduces the randomly introduce the missing values like nan values to the data set. Okay, so now we have introduced the missing values. Okay, so now I have splitted the data into training and testing. Okay, so I would just training and testing and copied the data that we will be using for the mean imputation, median imputation, mode imputation, and KNN imputer. Okay, so this is the basically same. We don't require this. Okay, let's see the mean. Okay, train mean. It's look like this. Okay, it contains the nan values. Okay, it contains the nan values. So using mean, we will be eliminating the nan values. Yes, we have imported the simple imputer. Okay, this is a simple imputer, and it has some strategies like mean, median, mode, and many more. Okay, so we have we have implemented the mean variation. Okay, so using this, the missing values will be filled with the mean of the entire column or entire feature. If the missing value of this is the mean of this entire column. Okay, now you understood, right? So now we can see here 14 nan value 14 2.97. This indicates that it is the mean of the entire column. You can also see this 2.97. This is also a missing value. Okay, now you understood, right? So let's see now how many nan values are present. Okay, so you can see still 30 values. Okay, we have changed the data set, right? Data set name. Okay, now you got zero. Okay, we have imputed the missing values using the mean method. So you understood the code, right? We just imported the simple imputer and we have just fit transformed it. Okay, now fit transform, and this is the data set and the entire data set. Okay, this indicates the entire data set. Okay, entire data set except one, except this. Okay, except this, the entire data set is fit transformed. Like the missing values are imputed by me. Similarly, we impute with the median also. We can see train median. Okay, now you can see 14. Here 14. is concluded as 3.5, but here it is concluded as 2.797. So this is the difference. It can change the structure, like it can change the pattern of the data. So when to use these kind of imputations, when the missing values are less than 5%, then we can use this imputation techniques like mean, median, mode. Okay. So if the missing data is more than 5%, we should not implement these kind of techniques. Okay. So this is the median method. Similarly, the mode method, most frequent means mode method. You can see train mode. Okay. Yes, if 14 is implemented as 1.4 because it is the mode of this data. It is the mode of this column. Okay. This is the KNN. Now let's see the KNN imputations. Okay. I have explained you that it will calculate according to the neighbors of it. Okay. I will tell you once. Okay. So you can see 14 is 7.5. How it is 7.5? First, it sorts the entire column, okay, and it will find the average of nearest in three nearest neighbors, okay, and the average of three nearest neighbors are for this 1.5. For 69, for 42, it's 1.4. But here you can see for 42, it's 1.4. But here there is some 42 here, it is 3.5, but here is 1.4. It will be changing. It will be changing the data. Okay, so now I understood what are this is the coding part of the imputation techniques. Okay, so we have discussed about imputation techniques. So now we'll be discussing about the outliers. Okay, what are the outliers? Okay, okay, outliers. So let us suppose you have a data like this. Okay, so you have a data like this. Okay, but few rows of data is like this. These are called outliers. Why these are called outliers? Because of these, if you perform the linear regression, because of these values, the regression line will be like this. Okay, and if we remove these outliers and perform linear regression, then the line will be like this. Okay, now you understood. The accuracy of this line is greater. Okay, rather than other line. Okay, that we have drawn before, like this line, the line one. This is line two. Okay, accuracy of line two is greater than accuracy of line one because of this outliers. So how we can remove these outliers? Is it necessary to remove the outliers? And the answer is it is necessary, and in some cases it is not necessary. So we should not blindly remove the outliers. So I will give you an example where we should not remove the outliers. Okay. So let us suppose you are working on a fraud detection. Okay. When you are working on the fraud detection, the outliers are the frauds. Outliers are the frauds, right? Outliers are important. In this case, the outliers are the have a very important nature while predicting the fraud detection, right? So we should not blindly remove the outliers. It may be used in some other cases also. Okay, like this. For example, is fraud detection. Okay, so and outliers should only be removed in training data set. Okay, only in training data set. We should not remove the outliers in the testing data set. Testing data set, we should not remove the outliers. Okay, because to test the model, we also need some outliers. So if the model predicts the outliers, then the model can be worse, right? So you should not remove the outliers to test the model very effectively. Okay, so there are some tips in the outliers. So the first one is Z-score. We already discussed about Z-score. So what is Z-score? So I already told you the formula, that is Z equal to X minus mu by standard deviation. So mu is mean, the observation, and this is the standard deviation. Okay. If the Z-score value lies between 3 and minus 3, then it is not outlier. Okay. If this condition satisfy, then it is not outlier. If it doesn't satisfy, we can remove the data. Like, you understood, right? If 1, 2, 1, 2, and there is a 9. So this value will be like 9 minus 1 by standard deviation is 1, 8. This is equal to 8. So 8 is greater than 3, right? 8 is greater than 3. So we can remove this data. This row we can be removing because it can affect the model performance. Okay, I understood, right? So this is the Z score. The other one is IQR. IQR. So in this, we will be measuring quantiles, percentiles, and removing the data, like detecting the data using those quantiles. Okay, and Q1 is the 25% of the quantile of the data, the entire data percentile. It's not percentage. 25% of percentile, 25 percentile. Okay, Q3 is 75 percentile. This is percentile, not percentage. Okay, so IQR is Q3 minus Q1. This is IQR, and the lower bound equal to Q1 Q1 minus 1.5 into IQR. Higher bound or upper bound equal to Q3 plus 1.5 into IQR. Okay, if the data, if the data, the column name is greater than uh, higher bound, or data less than lower bound, we can remove the data. Okay, we can remove the data. We can remove the data. These data can be removed. Okay, so this is the outliers. So there are only two outlier removal techniques, and many more. We can see that in these two are the very important techniques. One is Z-score. Okay, we can calculate the Z-score by observation minus mean by standard deviation. We can get the Z-score of the observation. Okay, if the observation is greater than 3 or less than minus 3, we can remove the row. We can remove the observation. Okay, so next the IQR thing is, first we need to find the 25% of the percent quantile of the data. Okay, we'll getting some value, and 75 quantile of the data, we'll getting some value, and IQR equal to Q3 minus Q1. Okay, and we can calculate the lower bound as Q1 means 25 quantile minus 1.5 into IQR. Okay, this is the lower bound, and the upper bound is 75 plus 75% time. Okay, 75% time plus 1.5 into IQR. We can remove the data which are out of these bounds. Okay, all right. This is the theory part of the outliers. Now we can see the coding part of. Okay, now let's see the coding part of the outliers. How we can remove the outliers. We have discussed that there are two methods. One is z-score and other one is IQR score. Like we will be removing the outliers based on it. Okay, so here is the outliers. How to remove the outliers? First, we need to calculate the z-score. Okay, the z-score, like I have imported the stats. Okay, I have imported the stats from Spicy. So this will it has inbuilt library as z-score. It has inbuilt library z-score. Okay, it will calculate the z-score of the entire columns. Okay, it will calculate the entire columns z-score. Okay, and if the z-score is less than threshold, the threshold is 3. We have discussed. If the z-score is less than 3, why not minus 3? Because we have used this absolute, okay, we have used the absolute. So if the z-score is less than 3, it can, it is not an outlier. If the z-score is not less than 3, then it is the outlier. Okay. Now, so we have written a code. Okay, it's a simple library that we can get from the Spicy. Okay, inbuilt method. We can say that. Okay, and this is the outlier. We can this is the IQR method to remove the outliers. Okay, so we have I have told you that Q1 is the percentile of 25 percentile of the data. So this is the quantile. Quantile means percentile, and this is the data at 75 percentile. Okay. Now IQR is Q3 minus Q1. Q3 minus Q1. Okay. So this is mask. So we calculated the outlier. Like, okay, this is the method. This is the variable which indicates if it is an outlier or not an outlier. You can see here. If the iLock is less than this or it is greater than this. Okay, now I understood, like if the value of this is less than the threshold lower bound, or if it is greater than the upper bound, threshold of the upper bound, it will not exist. Okay, that's why we use the negotiation. So negotiation means we can use this is the reverse. We can conclude it as a reverse. If the data is greater than this lower bound and less than the upper bound is mask. Okay. Now df of mask is the data which is in between the lower bound and upper bound. Okay. Now you understood, right? So this is the outlier. So now let's see the implementation. Now I understood these functions, right? These are the functions. These only two functions for the removal of outliers. Okay. So I have removed the data. Here you can see remove outlier z score. Outlier z score. It's mostly based on mathematics. That's it. Okay. No fit transform. No, everything is not used. Okay. So it's just an mathematical intuition to remove the outliers using z score and IQ. Okay. So we have removed the outliers. Okay. Impute now. The sixth step is impute test data. Now we haven't imputed the test data, right? We only imputed the training data. Okay. Now we have to impute the test data, and I will be showing the shape before and after the data. Now we know the coding part of this, like uh, imputer, mean imputer. Like mean imputer is nothing but it will be imputing based on the mean. So it will be transforming the dataset, the training dataset, testing dataset, and it will be imputing based on the mean. Okay, right? Now you can see the shape. Okay, see the original dataset shape is 80 and 5, 80 rows and 5 columns. The mean imputed 80 rows and 5 columns. Now see Here, the z-score filtration is 80,5. So it haven't removed any outlier. Okay. So, and when you come to IQR, it removes seven outliers. So, by this, we should conclude that we should use Z-score and IQR based upon the data. So, we should not blindly use any outlier method to any removal of outlier method. So, we should first study the data and then we should implement the anything you can say. Okay. In some cases the outliers are important, right? I've told you that in the fraud detection project, the outliers are important because it will only indicate the which is fraud and which is not fraud. Okay. So first we need to study the data set and then we need to start implementing or working on the data set. So this is the coding part of the outliers.